Okay, welcome to lesson 30 here. And before we get to the topic today and the goal, I just want to do a brief recap of yesterday, make sure we're comfortable. And like I said, just want to make sure you remember exactly what's happening here. So just a review of yesterday. So if we have the power rule here, the derivative is you take your exponent and you multiply it by the coefficient, x to the exponent, and the exponent will decrease by 1. So the exponent multiplies the coefficient, your exponent decreases by 1. If you have a negative exponent to start with, it means that the sign of the coefficient will change, and your exponent will become more negative. So please be careful when you're doing your subtraction. When you have a constant, the answer is always 0, so the derivative of any number by itself is 0. And if we have several terms being added or subtracted, you take each term individually and apply our derivative law. So we'd end up with n multiplied by a to the exponent x n minus 1 plus or minus m times b x to the exponent m minus 1 plus or minus c times p and then x to the exponent p minus 1. So you can treat each term individually. So that is, I always do the power and then the adding and subtracting rule all together because it really goes hand in hand. It's not something that needs to be separated. So today, the product rule is the topic for today. And what's the goal? I can recognize when it's necessary to use product rule, and I am able to successfully apply the product rule to the function. So let's talk about the product rule. What is the product rule? We've done power rule and now product rule. Product rule is when we have two functions multiplying each other. So I'm going to do a brief investigation. I'm going to tell you that f of x is equal to x cubed, g of x is equal to 2x squared. And we're going to take the derivative of each one. So if we take the derivative of x cubed, I end up with 3x squared. If I take the derivative of 2x squared from g of x here, I end up with 4x. So if I tell you that I want to take the derivative of a function that is really f times g, I want to figure out what is the expression for y prime. So what we're going to do is we're going to figure out what the right answer is to start. And we're going to do that by simplifying the expression. So f of x is just x cubed, and g of x is 2x squared. So I'm just going to use our exponent laws first before we take a derivative here. So it just becomes 2x to the fifth, just using our exponent laws. If I take the derivative of that, y prime would equal 10x to the fourth. So that's the right answer. That's where we got to get. So the question is, can we just multiply the derivatives together? Okay, is that our product rule? So we can test it to see if that's really the rule. And what we find is the derivative of f was 3x squared. And the derivative of g was 4x. So what that tells me, if we can put those together, we get 12x cubed. So the conclusion we can make here, okay, is that multiplying the derivative of f with the multiplying with the derivative of g is not equal to the derivative of f and g when they're being multiplied together. All right, so that tells us what it's not. So what is the derivative or the product rule? It really came from a bunch of trial and error, and finally some people put 2 and 2 together here and they realized that, hey, if I take the derivative of f and multiply it with the original function g and then added original function f multiplied with the derivative of g, what does that give us? So f of x multiplied by, or sorry, f prime of x multiplied by g of x, and leave the sign for a second here, f of x g prime of x, I would end up with 3x squared, g of x is 2x squared. Again, I'm leaving that sign out for the moment. X cubed is my original f of x, multiplied by 4x. I get 6x to the fourth. Here I get 4x to the fourth. I know the answer from down below is, the correct answer is 10x to the fourth. So if I add those together, I get the derivative. And that came from, obviously, trial and error and some deeper algebra than what I really want to go into today. So here's our conclusion. Okay? Product rule. If you want to find the derivative of two functions being multiplied together, it's always the derivative of the first, and order is very important here, people. Okay, it must be done in this order. Derivative of the first multiplied by just the second function, multiplied by, add just the original function multiplied by derivative, and the yellow are the derivatives there. Okay, so you definitely want that to go on the cheat sheet, but you're going to find after you practice it a while, you're going to find it taking up valuable space. So a couple of examples. Okay, what we have here are two functions. So my one function is the x squared plus 1. So that'd be f of x, and then my second function is the 2x cubed plus 2x. So taking the derivative of the first bracket, so if I want to find the derivative here, I take the derivative of the first bracket. So in there, the derivative of x squared plus 1 is going to be 2x, and the derivative of 1 is 0. And I leave that second function alone, plus my first function multiplied by the derivative of my second. So 2 times 3 is 6x squared, and the derivative of 2x is just 2. So there is the derivative. And again, I don't want you to simplify. All I'm doing is marking you on, can you take a derivative here? So we're not worrying about simplification at this point. Okay? And that's where you'd leave it. That's final answer for that question. What's the derivative of g of x? Well, I have two functions involved. So those are my two functions. So g prime of x. Actually, before you do g prime, let's just get rid of that. Oops, get rid of that notation, the radical notation. So g of x is going to equal x to the 1/2 and 3x to the 5th. Now I'm going to have some people here saying, hey, why don't I just multiply those together and just use power rule? Absolutely. I'm going to go ahead and use product rule just as an example, but you can definitely do that. So g prime of x, you take the derivative of the first function, so 1/2 x to the negative 1/2, multiplied by the second function, plus the first function multiplied by the derivative of the second, 15x to the 4th, and there is your derivative. And we're going to, again, we leave it in this form. I don't want simplification. I'm testing your ability to take derivatives in this course, not your algebra simplification. Your simplification rules are going to come in more into use in Unit 4. Okay, a couple more examples here. Again, we have our first function, and we have our second function. So we're going to take the derivative of the first, derivative of the second, so on and so forth. So h prime of x will equal derivative of the first, 6x to the 5th. Leave that second function alone, plus leave the first function alone, and multiply by the derivative of the second. Derivative of x squared is 2x. Derivative of 7x is 7. Derivative of negative 1 is 0. So there we are. So there is the derivative of that function h. Next one, number 4. First thing I'm going to do again, I'm going to rewrite this function without any radical signs. Just makes it a little bit easier. My derivative then is the derivative of the first function, so negative 4x to the negative 5, multiplied by the second function, plus leave the original first function alone and take the derivative of the second. So 1/2 x to the negative 1/2 minus 6x squared, derivative of 1 is 0. So remember, you're taking the derivative. If you look back in the homework in the start of this unit, doing it from first principles, think about how hard these questions would be. with doing it by first principle. Now you're doing more complicated functions in one line and coming up with an expression for slope. Because remember, this is an expression. Had a mind cramp there for a second. For the value of slope of the tangent anywhere on the graph. So it doesn't matter where you are on the graph, this is the equation for the slope of the tangent. Okay? And you're doing it in one step, so significantly quicker than it was before. Okay? That must have been it. Sorry. So I could have rambled a little bit more there. But there's the assigned homework. And like I said, keep in mind, this process is just a shortcut for what you were doing before from doing it from first principles. All right? So, any questions with homework, let me know, and I'll give you a hint.